Betelgeuse, the mysterious red supergiant. Betelgeuse is a massive red supergiant star situated in the Orion constellation. It has intrigued humanity for many centuries with its rich crimson glow and enormous dimensions. According to astronomers, if Betelgeuse were placed at the center of our solar system, it would consume every planet up to Jupiter. This star is so massive that it symbolizes the final stage of stellar evolution, as if it were about to end in a spectacular supernova explosion. In recent years, Betelgeuse has started to show strange behavior. In a surprising twist, its brightness surged, increasing by 50%, making it rise from the 10th brightest star to the 7th in the night sky. This sudden increase in luminosity left scientists scrambling for an explanation. Was this the beginning of its catastrophic end or merely a temporary anomaly in its life cycle? The effects of Betelgeuse undergoing a supernova would be enormous. It could transform the night into day, offering unmatched opportunities for scientific discovery. A star's luminosity is influenced by factors such as size, temperature, and its distance from Earth. Betelgeuse, which has a radius more than 700 times that of our Sun, is relatively cool, with surface temperatures ranging between 3000 and 3500 Kelvin. This coolness gives it its distinctive red color. Despite its immense size, Betelgeuse's cooler temperature makes it a prime candidate for a supernova, which is why its recent behavior has captured such keen interest. In late 2019, Betelgeuse astonished astronomers once more by dimming to just 40% of its usual brightness. This phenomenon, visible even to the naked eye, sparked a wave of observation and debate. Some speculated that the dimming was caused by dust blocking the star's light, while others believed internal processes were at play. The idea of an impending supernova became the focal point of discussions. Utilizing the Very Large Telescope, VLT, in Chile, astronomers were able to capture detailed images of Betelgeuse during its dimming phase. These images revealed that the star had developed a distinctive, lopsided appearance. Further examination showed that the dimming was likely due to a massive surface mass ejection, SME, during which Betelgeuse expelled a tremendous amount of material into space. This extraordinary event reshaped the star and disrupted its pulsation cycle. It was comparable to a volcanic eruption on a cosmic scale, with Betelgeuse releasing 400 billion tons, 400 times more material than what a typical solar event would produce. This upheaval not only changed the star's appearance but also shortened its pulsation period from 400 days to just 200 days. These dramatic shifts point to Betelgeuse becoming increasingly unstable, raising the question, how long can it maintain its current state? The recent developments in Betelgeuse's behavior have prompted astronomers to intensify their observations, searching for further signs of its impending collapse. When a massive star like Betelgeuse exhausts its nuclear fuel, its core collapses under the force of gravity, triggering a supernova. This explosion releases an immense amount of energy, ejecting the star's outer layers into space and creating a dazzling light show that could be seen even during the day. If Betelgeuse were to explode, the first sign would be a surge of neutrinos, subatomic particles that move more quickly than light and can escape from the star's core. These neutrinos would reach Earth hours before the light of the explosion. When the light finally reaches us, Betelgeuse would shine brighter than the full moon, casting shadows and turning night into day for weeks. A Betelgeuse supernova would provide scientists with an unparalleled opportunity to study stellar death in real time. By observing the light, heat, and radiation emitted during the explosion, researchers could gain valuable insights into stellar evolution, nuclear physics, and the formation of elements that make up planets and life itself. To better comprehend Betelgeuse's behavior, scientists are using advanced simulations to model the star's interior. These virtual models incorporate data from telescopes such as the James Webb Space Telescope, JWST, and the VLT, allowing researchers to investigate the processes driving Betelgeuse's instability. Simulations suggest that a massive gas bubble may have risen from deep within the star, triggering the SME and altering its pulsation rhythm. The JWST has also provided a closer look at the material ejected by Betelgeuse, revealing complex structures of gas and dust surrounding the star. These observations point to the possibility that Betelgeuse may be entering its final stages, providing an unprecedented look into the life cycle of a massive star. While scientists estimate that Betelgeuse could go supernova within the next 10,000 to 100,000 years, its behavior suggests that this timeline may be much shorter. The astronomical community is working tirelessly to capture every detail of this cosmic drama before it reaches its dramatic final act, ensuring that humanity does not miss this once-in-a-lifetime event. In late 2023, the JWST focused its extraordinary capabilities on Betelgeuse, uncovering a startling phenomenon. Scientists discovered that, already unstable from its massive surface mass ejection, the star had experienced a rapid internal collapse. This collapse was evidenced by significant shifts in its core dynamics, which altered the flow of nuclear fusion reactions within the star. Astronomers observed dramatic fluctuations in Betelgeuse's pulsation cycles. Before the collapse, the star's surface expanded and contracted steadily over 400 days. Afterward, this rhythm abruptly changed to a 200-day cycle, signaling a massive disruption in the star's internal structure. This irregularity is akin to a cosmic heartbeat, suggesting that Betelgeuse is nearing the end of its stellar existence. Simulations created by astrophysicists revealed that Betelgeuse's core was becoming increasingly unstable as it fused heavier elements. When stars reach this stage, they begin producing iron, a process that signifies the final phase before collapse. Unlike other elements, iron does not produce energy when fused, creating a buildup of mass that forces the core toward an inevitable collapse. Betelgeuse's recent implosive behavior has sparked heated debates among astronomers regarding its supernova timeline. While some believe the findings suggest that the explosion could take place within the next few centuries, others argue that it might still be thousands of years away. One thing is clear: Betelgeuse's time as a red supergiant is running out. A key indicator of an imminent supernova is the emission of escaping neutrinos from the star's core just moments before it collapses. Scientists are closely monitoring Betelgeuse for any sudden increase in neutrino emissions, as this would serve as the first real-time warning of a supernova. The entire world is on high alert, prepared to recognize this brief signal. While Betelgeuse's supernova will undoubtedly be an awe-inspiring celestial event, visible even during the day, scientists assure us that it poses no danger to Earth. However, its brightness could rival that of the full moon, casting eerie shadows and lighting up the night sky for weeks. This event will not only captivate stargazers but also offer an exceptional opportunity for scientific research. The story of Betelgeuse reminds us that the universe is full of mysteries waiting to be unraveled. The future of Betelgeuse and the implications for astronomy. As Betelgeuse continues to evolve unpredictably, astronomers remain on high alert, closely monitoring every fluctuation in its brightness, temperature, and spectral emissions. Telescopes across the world, both ground-based and space-based, have dedicated extensive observation time to tracking the star's every move. The goal is to detect any signs that could indicate an impending supernova, such as rapid shifts in its core structure, increased neutrino emissions, or sudden bursts of high-energy radiation. A supernova from Betelgeuse would not only be a breathtaking celestial event but also a once-in-a-lifetime scientific opportunity. Such an explosion would allow researchers to study the physics of supernovae in real time, something that has never been directly observed in a star so close to Earth. This event would provide crucial data on the final stages of stellar evolution, the distribution of heavy elements into space, and the impact of such cosmic explosions on nearby planetary systems. The role of advanced technology in stellar observation. The James Webb Space Telescope, JWST, along with other observatories like the Hubble Space Telescope and the Chandra X-ray Observatory, has revolutionized our ability to peer inside dying stars like Betelgeuse. Infrared imaging from JWST has revealed intricate details of the material ejected from Betelgeuse, allowing scientists to track how the expelled gas and dust interact with the surrounding interstellar medium. Similarly, radio telescopes such as ALMA, Atacama Large Millimeter-Submillimeter Array, have provided insights into the star's outer layers, revealing complex structures and unexpected asymmetries. These observations suggest that Betelgeuse's outer shell is not uniform but rather shaped by powerful stellar winds, convection currents, and possibly magnetic fields. What happens after the supernova? When Betelgeuse eventually explodes, it will leave behind either a neutron star or, if its core is massive enough, a black hole. A neutron star, a dense remnant only a few kilometers in diameter, would emit powerful radiation in the form of X-rays and gamma rays. If Betelgeuse instead forms a black hole, it would mark one of the closest stellar mass black holes ever observed. Either scenario would present astronomers with an invaluable opportunity to study these exotic objects. Additionally, the supernova explosion would enrich the surrounding interstellar space with elements such as oxygen, carbon, silicon, and iron, elements that are essential for the formation of new stars, planets, and even life itself. In this way, Betelgeuse's death would contribute to the ongoing cycle of cosmic evolution, seeding the universe with materials that may one day form new solar systems. The human connection, Betelgeuse in culture and history. Beyond its scientific significance, Betelgeuse has held a place in human culture and mythology for centuries. In ancient civilizations, the star was used as a marker for seasonal changes, guiding agricultural practices and navigation. In modern times, its ominous variability has inspired science fiction stories, films, and speculation about the end of days. As we await the eventual fate of Betelgeuse, humanity is witnessing history in the making. Whether it explodes tomorrow or in 100,000 years, its final act will be one of the most spectacular astronomical events ever observed. Until that day arrives, astronomers will continue watching, learning, and preparing for the moment when the night sky changes forever. Simulations study the dynamics of stars and look billions of years into the past, all in an effort to better understand the fabric of reality itself. For scientists like Neil deGrasse Tyson and researchers worldwide, discoveries like these spark a sense of urgency and excitement. They push the boundaries of human knowledge and challenge us to continue exploring the cosmos. The next time you look up at Orion's belt, remember that one of those points of light holds the story of a star on the edge of its destiny. What do you think will happen to Betelgeuse? Are we witnessing the final moments of a star about to explode, or is it simply another phase in its mysterious life? Share your thoughts in the comments and join the conversation about one of the most fascinating stars in the universe. Don't forget to like, subscribe, and turn on notifications for more cosmic stories that will blow your mind. Until next time, keep an eye on the sky. One of the most unusual and captivating aspects of Betelgeuse's behavior is its unpredictability. The fact that such a colossal object, visible to the naked eye from Earth, is undergoing rapid and drastic transformations that scientists are struggling to predict underscores the complexity of stellar evolution. What makes Betelgeuse especially intriguing is that it is nearing the end of its life cycle, making it an extremely valuable subject for study. In essence, it offers a real-time look at the processes that occur prior to a star encountering its explosive fate, a rare and extraordinary opportunity in the field of astronomy. The latest data from various telescopes has opened new avenues of exploration. As scientists continue to probe the details of Betelgeuse's behavior, they are uncovering intricate details of its structure that were previously hidden from view. These details are critical in understanding how massive stars undergo their final transformations. For example, astronomers have pinpointed that the star's core is slowly becoming more unstable, signaling that it may soon begin the process of fusion that will lead to the creation of heavier elements like iron. The production of iron within the star is a key indicator that Betelgeuse is approaching its final moments. This process cannot support the core's energy requirements, triggering the star's collapse. The concept of a supernova is awe-inspiring. It represents one of the most powerful and spectacular events in the universe, releasing vast amounts of energy, much of it in the form of light, heat, and radiation. For the first time in history, humanity will have the chance to study such an event in detail, potentially gaining insights that could change our understanding of the universe itself. The intensity of the explosion, combined with the vast quantities of elements expelled into space, has the potential to alter our comprehension of everything, from the life cycle of stars to the very creation of planet-forming substances, and possibly even life itself. By closely examining the details of Betelgeuse's eventual explosion, scientists could discover new ways to study stellar phenomena in unprecedented detail. In addition to understanding stellar evolution, Betelgeuse's supernova may also have broader implications for fields like nuclear physics. The precise way in which heavy elements are created during a supernova could provide a much-needed glimpse into processes that have been theorized but never fully understood. The enormous amounts of energy released during the collapse of Betelgeuse's core will offer valuable data for understanding the forces at play during stellar collapse and the behavior of atomic nuclei under extreme conditions. In many ways, Betelgeuse's impending fate also holds deep philosophical significance. It forces us to face the ephemeral nature of stars and, by extension, the impermanence of all things in the universe. While we may not be alive to witness Betelgeuse's actual explosion, since the event may not occur for tens of thousands of years, the study of its final stages gives us a unique perspective on the life cycle of stars. This information will remain essential for future generations, helping us understand the very nature of our universe, from its birth to its inevitable decay. Looking beyond Betelgeuse, the lessons gleaned from this extraordinary star will also influence our understanding of other stars, including our own Sun. While our Sun is not massive enough to end its life in a supernova, the processes that govern stellar evolution apply universally. Studying a massive star like Betelgeuse can offer insight into the eventual fate of all stars. In the distant future, we may come to understand more about the vast distances between stars, the processes that govern their formation, and the intricate ways that stars influence the environments around them. Whether or not we will ever be able to observe Betelgeuse's explosion firsthand, its story will be crucial in shaping our broader comprehension of the universe. As the scientific community pushes the limits of current technology to observe and analyze Betelgeuse, new breakthroughs in telescope technology, computational simulations, and data analysis are continually transforming our approach to stellar research. With each advancement, scientists are inching closer to understanding how the universe operates on its most fundamental level. These advances not only help us unlock the mysteries of individual stars but also contribute to our overall knowledge of galactic evolution and the broader cosmic narrative. The quest for answers about Betelgeuse is part of a larger movement within the scientific community to explore the unknown and answer the most profound questions about our existence. What is the fate of the stars? What is the ultimate destiny of the elements that make up everything around us? How do the building blocks of life come together to form the galaxies, stars, and planets we see in the night sky? The search for answers to these questions is one of the driving forces behind much of current astronomical research, with Betelgeuse serving as an essential case study. As technology advances, our ability to observe and analyze celestial phenomena will only improve. Future telescopes, such as the James Webb Space Telescope and its successors, will provide even more detailed insights into the life cycle of stars like Betelgeuse. These instruments will allow astronomers to detect subtle changes in the star's structure, temperature, and brightness, offering a clearer picture of what is happening beneath its turbulent surface. Beyond telescopes, advancements in computational simulations will enable scientists to model the internal processes of Betelgeuse with unprecedented accuracy. These simulations will help refine predictions about when and how the star might explode, giving us a better understanding of the final moments of massive stars. But what would happen if Betelgeuse were to go supernova in our lifetime? The event would be one of the most spectacular cosmic displays ever witnessed. The explosion would likely be visible even during the day, shining as brightly as a full moon for weeks. Astronomers around the world would turn their instruments toward Betelgeuse, capturing every stage of its transformation in real time. The aftermath of the explosion would also be of great scientific interest. The supernova remnant left behind would enrich the surrounding interstellar medium with newly formed elements, contributing to the cosmic cycle of matter. In time, these elements might become part of new stars, planets, and even life itself, continuing the grand story of stellar evolution. This concept, that we are all made of stardust, underscores the profound connection between the cosmos and life on Earth. The atoms in our bodies were forged in the cores of ancient stars, and the death of a massive star like Betelgeuse is a reminder of the ongoing cosmic processes that make existence possible. Looking ahead, scientists will continue to monitor Betelgeuse closely, eager for any sign that the star is approaching its explosive finale. Whether that moment comes within our lifetime or thousands of years from now, one thing is certain. Betelgeuse's fate will forever be a crucial piece of the puzzle in our quest to understand the universe. Until then, we can only watch, wait, and marvel at the mysteries of the stars above.